Hey guys, welcome back to the video on coding stacks and queues in Python. I hope you have already watched the theory part of stacks and queues which I explained on board in my previous video. Now let's do coding and let's see how to implement stacks and queues in Python. Okay, we'll just write a class for stack and let me name it as stack, and let me initialize the class stack. Okay, let me write self.s equal to a empty list. A empty list means empty stack. This is just a list, and when you call this list using this class stack, this becomes a stack virtually. Okay, now let me just push the elements onto the stack. We will write a method for pushing the elements. Define push. As I already explained, the first parameter will be self and the second parameter will be the element. We need to specify the element which we need to push onto the stack, right? That's why self.s.append, cause I already told you that the push operation on a stack is nothing but an append operation on a list, right? Yeah, what should I append on the stack? The element, right? That's why ele. Okay, now let me write a method to pop an element from the stack. Let me write as pop, and pop doesn't take any kind of arguments other than self because this is a class. Okay, now self.s.pop. Okay, this will pop the topmost element in the stack. That means the last element which was appended onto the stack or pushed onto the stack will be popped. Let me write a method to get the size of the stack. Let me name it as size. This also doesn't take any arguments other than self. Let me return, because this has to return some value, that's why I'm using return statement. Even I have to use return statement over here because the console has to return you the popped element also. That's why. Okay, now define size. Return length of self.s. That will give me the size of the stack, right? As I already explained you, the length of this list or stack will be the size of the stack. That's why guys, I'm telling you, just go and watch the previous video once, in which I have explained all the theory concepts, and come back to this video. Now let me get the isEmpty method. This will return a boolean value if whether true or false, that is whether stack is empty or not. That's why I will return length of self.s equal to 0, and I'll also write a method to peek at the topmost element in the stack. This will return self.s. This will return self.s of 0. Okay, even we can take self.s of length of self.s minus 1. If we take len of self.s minus 1, this will return, like, assume that you have 3 elements in the stack. This will return the third element, and if you use 0 over here, this will return the first element in the stack. So you need not use that method. Okay, it's fine. Okay, now let me create an object of the class stack. Let me name it as stsk. Here the small stsk is an object of this class named stack. Okay, now I have to call those methods inside the stack, right? Initially the stack will be empty. Let me check. Stack dot is empty. Yeah, it is true, and the stack dot size will be 0. See, because there are no elements in the stack, it is initialized to a empty list. Okay, now let's push some elements onto the stack. Stack.push will push 1. I'll just copy this line. Okay, we are pushing 3 elements onto the stack here. Stack.push1, stack.push2 and stack.push3. Okay, there's no error. We'll check whether the stack has those elements or not. So this 1 got pushed first, then 2, then 3. According to stack's principle, that is last in first out, when I do a pop operation on this stack right now, it should pop the element 3, right? Let us check. Yes, we got 3. We will pop it again. Stack.pop. It returned 2. Cause 3 was no more in the stack and 2 was the topmost element. That is the last element which was appended onto the stack. Okay, now there's only one element in the stack left, right? That is 1. Cause both 3 and 2 are popped, I'll get the size of the stack. I'll get the size. Stack size is 1 and I'll check stack is empty or not. It's false. Yeah, it was easy, right? Cause stack is not empty, it has one element in it. That's all what a stack is. It's a very easy data structure, but I can say, but it's an important data structure. That's what I can say. Okay, now let us code the queue. I'll take class queue for it. Wait, we'll just copy these lines. Cause queue is not that different from stack, right? We'll initialize self.s to an empty list for now. As I explained, the push operation is not append operation on stack. It is an insert statement which takes 2 parameters. The first is the position, that is 0, and the element itself. And pop is nothing but self.s.pop. And guys, one more thing, this push is also nothing but enqueue. If many of you got confused in the previous video why he is not explaining enqueue and dequeue, this push is nothing but enqueue and pop is nothing but dequeue. Okay, there's no rocket science in it. Okay, again this define size will return the length of the queue and isEmpty will return whether the queue is empty or not. Okay, I'll run it. Now we'll just create an object of the class queue. Let me name it as queue is equal to queue. Now what we'll do is we'll just check whether the queue is empty or not. Queue dot size is 0 and queue dot is empty is true. Yeah, it's right. Okay, now let's enqueue or push some elements onto the queue. I'll just copy this line. Okay, we have successfully enqueued 3 elements onto this queue and we'll just try to pop those elements. We should not use pop, guys, as we have used dequeue over here. We have to use dequeue over here. If we had used pop instead of dequeue, we would have used pop itself, but as we have used dequeue, we have to use dequeue. And dequeue doesn't take any kind of positional arguments, that's why we'll just leave it. It has returned 1. Yeah, right? Because stack follows last in first out, whether queue follows first in first out. The first element which was pushed onto the queue was 1, that's why it is the first element which is pushed out of the queue. Let me do this operation again. 2. Yeah, we are right. I'll just check the size. It should return 1. Let me check whether the queue is empty or not. It should return false. Yeah, and I'll just dequeue this again. It should return 3 and size should be 0. Is empty should return true, right? Yeah, it's true. Okay, what's basically happening over here is when I call this queue, it creates an object of this class queue, and in order to access the methods of the class we need to use this object, right? That's what I'm doing over here. I'm using this object to access this method, the size method, which is in this class. You got that? And I'm using the queue object to in order to access the method which is empty, which is present inside this class queue. That's what. It's just a basic object oriented programming. That was all for this video. I hope you all guys got it, how to code stacks and queues in Python. Let me see you in my next video with some more concepts on how to approach for a problem in competitive programming or practice programming and how to solve the question. Thank you.